Good morning, this is Dr. Turner for Integrated Math 2. Today we're going to be getting into 9.1, which is looking at cross-sections and nets of solids. This may be a little bit of review for you, in which case that's great, and if it's new information, that's great too. So we're looking at two concepts here as we get into a geometry unit involving area, volume, surface area, all kinds of fun stuff. But the first thing we're going to be looking at is cross-sections and nets. Now, nets are probably what you're introduced to first, maybe even back as far as 6th grade. But the net of a figure is when you take a three-dimensional shape and you are essentially unfolding it, or you're looking at just the outside of the shape. So if I took a three-dimensional shape, let's say I took a cube, and I was to unfold it, or take it apart, and just look at the flat surface, that's what we refer to as a net. So for a cube, and nets are always going to be in relation to a three-dimensional shape. If I take a cube, then the net would look like this. It's showing all the outside connected into one. So you'll have a few questions on your assignment. They're going to be simply that, asking you to identify what's, either what the net of a three-dimensional shape is, or given the net of a shape, be able to identify what three-dimensional shape it is when it's put together. Now, typically for polyhedrons, so shapes that just have shapes that are polygons, squares, triangles, things like that on the outside, a lot of students are okay with that. What will sometimes throw students off is when we look at surfaces that are curved. So let's say a cylinder or a cone, things like that, because you have both a curved surface and a flat surface, and that throws students off. So for instance, if I took, let's say, a soda can, for instance, soda cans are cylindrical, and I were to look at the outside of that shape, of course we have circles on the top and bottom, and a lot of students, can visually represent that, but what throws students off is that in the net of a cylinder, you also have a rectangle. And so the way that I picture it is if I were to take something, let's say like a water bottle, and I have a label that's going around the outside. Well, if you were to unfurl that label, right, you end up with a rectangle. So imagine you could do that with the entire side of the water bottle. Even though it is curved, it's going around a curved surface, when you unwrap it, you get a rectangle. So that's the idea behind nets. You're just comparing what you're getting, right, from dissecting it, if you will, folding out the outside parts, and then being able to put it back together. That's a net. When you look at a cross section, it's like taking a slice out of a three-dimensional shape. So for instance, if I took this soda can, and imagine I had a very sharp knife, and I was able to cut a two-dimensional shape off the top, of course on the top of a soda can, that's going to be circle, right? However, if I were to cut it this way, that would not be circular, and that's what throws students off. So when you're talking about cross sections, it's either going to say either parallel to the base or perpendicular to the base. You can take a diagonal cross section as well, but those are less common. If we were in person, we'd be talking about those a little bit more. So let's go back to the cube here, for instance. Now, a cube doesn't matter, right? Because if I cut it either horizontally or if I cut it vertically, each side of a cube is just a square, right? So it doesn't matter for a cube which way I cut it. It'd be similar with a rectangular prism. If I cut it horizontally or vertically, I'm going to end up with a rectangle in that case if it's a rectangular prism. Now with all other shapes, and for us we're focusing primarily on cubes, rectangular prisms, spheres, and cylinders, those will change depending on which way I'm dissecting it. So for instance, like we said, in a cylinder, if I take a cylinder and I cut it parallel to the base, okay, then that's going to give me a circle. However, if I were to cut it perpendicular to the base going up and down, it's kind of harder to imagine, but if this was a two-dimensional shape and I were to cut it, then this forms a rectangle. Now that confuses a lot of students. The way I think of it is, either you're cutting it like you would a stack of bologna, or if you were able to smash the shape down. So for instance, if I took a can and I smashed it down, right, then that forms a rectangle. So depending on which way you cut a cylinder, you're either going to get a circle or a rectangle depending on which way you slice it. So pay attention to the directions, because you'll have diagrams that will look exactly the same, but one will say parallel, and then on another question it will say perpendicular. So be careful with that. Similarly, I don't have anything fancy for you here, but for a cone, it's going to be a very similar process. So if I took a cone, imagine like an ice cream cone, for instance, and if you were to cut it, parallel to the base, that's circular in shape. However, if you were to take the cone and cut it perpendicular to the base, then you end up with, imagining that this is flat, a triangular shape. So pay attention to the directions. Is it asking you to take the cross section parallel, or is it asking you to take the cross section perpendicular? There are more examples and pictures in the PowerPoint and supplemental resources, so if you guys want to access that, those are available to you on the Schoology page. But otherwise, have a good day, and I will talk to you soon. Bye.